Hi everyone. In this section we're just going to build up some fundamentals in terms of understanding polynomials and some basic characteristics of the graphs and things that will inform our understanding deeper concepts of polynomials to come here. So first of all, we want to understand what a polynomial is, as well as to tell what kind of types of polynomials there are out there that we want to be familiar with. So ultimately what a polynomial is going to be, if it's in one variable, is it's going to have just a bunch of those variables raised to whole number exponents, all added up, and then can also get multiplied by coefficients. So right now, I'm just adding up a bunch of variables x's that are raised to powers. So I started at the n power, and then a exponent that would be one lower, n minus 1, and then one lower than that, etc. Okay, so then I'm just going to skip a whole bunch of terms, and then eventually it'll end where we have, like x to the 2, and x to the first, and then at the end there is allowed to be some number, some constant n at the end. So then I'm going to change colors right here, because then we could have all of these constants that could be coefficients of the variable terms get added right there. But it wouldn't be appropriate to call them all a, because they're most of the time not always going to be the same numbers, right? So what I might do then is I call this a sub 1, or no, sorry, call that a sub 0, and then call this a sub 1, call this a sub 2. So I'm just kind of labeling each of the a's, so if they're all different variables, and just the label that I use just happens to match with the number of the exponent on an x each time. So that's basically going to be what a polynomial is. So just know that all of the a sub i's are going to be real numbers, and therefore we'll get a polynomial that we would call a real polynomial, because all those coefficients are going to be real numbers, right? Okay, so let me give you like a specific example of what a polynomial might actually look like then. So if you had something like negative 2/5 x to the 7th plus 3x to the 5th minus 4x squared plus square root 3 times x minus pi. That would be an example of a polynomial. So the reason why that's going to be a polynomial is because we have that all of these exponents here on the variable x, they are all whole numbers. So if we had fractions or negative numbers, that sort of thing, they would not be whole numbers, right? Because to be a whole number means that it needs to start at 0 and then count upwards and have no fractions or decimals, right? And then also all of these coefficients of the variable terms here, they're all real numbers, and so then we get a real polynomial. Okay, so just note that we do give specific names to the particular terms. So the number that gets added is always known as the constant term, and then the term that has a 1 on the exponent of x, this is always known as the linear term. And that kind of makes sense because so far, if you look at only just the last two terms, it would kind of be of an mx plus b form. So like the last two terms would always form a line, right? Because it's mx plus b. And then this term right here is called the quadratic term. And then that makes sense because then the last three terms would be like the form of a quadratic expression, right? ax squared plus bx plus c. So if there was appearing here an ax to the third term, then that would be the cubic term. And then if there's an ax to the fourth term, then that would be known as the quartic term, like 4 quarts in a gallon. I'm out of room, so like imagine that there was an ax to the fifth term. That would be known as the quintic term. And then if there's like an ax to the sixth term, some people might call that like the sextic term. For our purposes, I think what we'll do is just when it gets to an exponent of 6 or higher, then we'll just call it that nth degree term. So this here would just be like the 6th degree term, and ax to the 7th would be the 7th degree, etc., right? So if the exponent was 12, we'll just say it's the 12th degree term, etc. Okay? So if you put all that stuff together then and you set it equal to y, then that would be a polynomial function, right? So if y equals some sort of polynomial, that would be a polynomial function, right? So I talked about all the terms. The other thing that you want to know about then too is this term right here, the one that has the highest exponent, is always known as the leading term of the polynomial. So it's always the one with the highest exponent, which then makes the a number itself that's in front of the leading term known as the leading coefficient, because it is the coefficient of the leading term. And then furthermore, there's something that's known as the degree of a polynomial, and the degree of the polynomial is going to be the exponent that is the highest among all of the individual terms. So you're always going to find it in the leading term then. So particularly, it's going to be the number n then, right? So like in this polynomial right here, we would say that the leading term of it would be negative 2/5 x to the 7th, because that's the term that has the highest exponent in it. The leading coefficient would be negative 2/5, and then the degree of the polynomial would be 7, because it's the highest exponent, okay? So looking at some examples of some of the terminology here, you can see that we're asked to identify each of the following for f of x equals negative 9/8 x to the 3rd plus pi over 2x squared minus square root of 5x minus 9.5. So one thing we're asked for is we're asked for the degree. That means the highest exponent of all of the terms. So this is a degree 3 term, a degree 2 term. This is a degree 1 term. And a constant term is always a degree 0 term, because you can think about it as being multiplied by x to the 0, which then would just be times 1, because to the 0 power means it's 1. So then the highest degree term is going to be degree 3, right? So that's the degree of the whole polynomial then, is a degree 3 polynomial. The leading coefficient, so we know that like this right here is going to be the leading term because it has the highest exponent of 3. So its coefficient is negative 9/8, so that's going to be the leading coefficient of the polynomial then. And then the leading term would be the whole term that is the leading one that has the highest exponent, so negative 9/8 x to the 3rd. Constant term, so the constant, right, is just that number that gets added or subtracted with the polynomial, which in this case is that negative 9.5. Make sure you have the negative there, because that is negative, okay? And then the linear term. Linear is always going to be the term that has an exponent of 1 on x, so that would be that term that you're seeing right there. Make sure that you include the negative as well with that coefficient of square root 5, so that's going to be the whole term, linear term. And then this right here is only asking for the coefficient, right? It's only the number that times with the variable part of it. And we want the quadratic one. Quadratic means that you'd have an exponent of 2, so then we're looking at that term right there, the pi over 2 x squared, but we want only the coefficient, so make sure you only indicate that as then being pi over 2. Okay? All right. So when we look at some example polynomials here, you can see that in order, we are kind of going by degree right here, where this is a degree 0 polynomial all the way to a degree 5 in order. It gives you some examples of things, okay? So we can actually classify the whole polynomial according to its degree. So because this polynomial right here is a degree 0 polynomial, because it's the highest exponent on x, right, because you can think of it as 4 times x to the 0, then you would actually call the entire polynomial, or the entire equation right here, a constant polynomial. And that makes sense, because y equals 4 is going to be a constant function, right? It's just going to be a flat horizontal line, okay? And then whenever the highest exponent or the degree of the polynomial is 1, you will always be able to call that function a linear polynomial. And that makes sense because it's in mx plus b form, right? We know that lines are always like that, so then it's linear. And then to no surprise, you already know that when the highest exponent is 2 in a polynomial, we'll be able to call that a quadratic function, okay? So then when the highest exponent is 3, it's cubic. When the highest exponent is 4, it's quartic. And the polynomial is a quintic polynomial if the degree is 5. And then if it's 6 plus, then we're just going to say that it's 6th, 7th, 8th, 9th, that sort of thing in terms of the degree of the polynomial. Okay? So not only can we classify polynomials according to their degree, but also we can classify polynomials according to the number of terms that they have. So this polynomial right here, we would be able to classify it as being a monomial, because mono means 1, and there's only one term, just the 4. Versus this polynomial right here, there's actually 2 separate terms being added. You have the 5/8 x term added with the negative 7. So we call those sorts of things where there's 2 terms a binomial, because bi means 2. And then right here, this has three separate terms because you got the x squared term, you got the x term, and the constant term. So then that's going to be called a trinomial because tri means three. Okay. Beyond that, we don't give any other names when there's four or more terms. So we only do mono, bi, and tri. So beyond that, if there are going to be four or more terms, then we're just going to have to call it a polynomial, where poly means many, right? So because like this one right here has four terms, then you'd be able to classify this as being a polynomial, okay? And you'd be back to try right there because there's, you know, three terms in that one. That one's got four terms, so then you're just going to call it a polynomial, okay? But do recognize that all of these right here, where there were only one, two, or three, you can still call them polynomials because polynomials can have any number of terms. It's just the ones that have four or more terms that we don't have anything like really more specific than polynomial to call it, okay? So here we're asked to classify each polynomial function by its degree as well as by its number of terms. So when you have to give what type it is by its degree, that's going to be like, you know, if it's cubic because it's degree 3, or if it's constant because it's degree 0, right? And then when you classify it by how many terms it has, that's going to be like mono, bi, tri, what may have you, right? So when you look at the first function right there, you can see that the degree is going to be 1, because that's the highest exponent of x. So therefore, this has to be a linear polynomial. That would classify it by its degree. And then also, it only has one term, just that monomial 1/7 x. So therefore, we would classify this polynomial as being specifically a linear monomial. Okay. This guy right here is also going to be a monomial because it only has one term of 1/7. The degree of that is 0 because it's just a constant. So then we would classify it as being a constant polynomial because it has degree 0. So therefore, it's a constant monomial. Degree 0 and only one term, right? When you look at the next one, you can see there are three separate terms. So you'll be able to call it a trinomial when there are three separate terms. And then the degree of the polynomial is 2 because it's the highest exponent. Those sorts of things are always quadratic. So therefore, this is a quadratic trinomial. And then this one right here, gotta be careful because actually the highest exponent is 6. So therefore, this will be a 6th degree. And then it has only two terms, just the 6th degree term and then the quintic term, right? So this would be a binomial because there are two terms in that. And then the next one, you're only going to be able to call this a polynomial most specifically because there are more than three terms. There's actually like 5 terms, right? The highest exponent is 4, so it's degree 4, which you should call it quartic whenever it's degree 4. And then the last one is just one single term, so that's going to be a monomial. And then it's got a highest exponent of 3, so then that's going to be a cubic function. So a cubic monomial then when we classify that by its degree and its number of terms. I want to make sure that you understand some things that are not going to be polynomials. So indeed, all 6 of these in the table equations are actually not going to be polynomials. So the reason why this one's not a polynomial is because the exponent here is not a whole number. So remember when I said earlier that for polynomials we need the exponents to be whole numbers? That means that we want it to be whole numbers that are of this kind of whole. 0 and higher with no decimals or fractions, right? So because we have the square root of x right there, that means that we have x to the 1/2, and 1/2 is not a whole number. So therefore that doesn't work, right? This term right here could be rewritten as 4/3 times x to the -3. Again, -3 is not a whole number. Whole numbers have to be 0 and higher, okay? So it's not going to be a polynomial. Same reason right there, the exponent is not a whole number, okay? So all 3 of the top examples, right, didn't have all exponents that were whole numbers, so they can't be polynomials, okay? This one's got a little bit of a different reason why it's not going to be a polynomial. So you'll actually see that like x is in the exponent, which is not what we want in polynomials. In polynomials, we need x to be the base, and then the exponents can only be whole numbers, okay? So what this function is right here is it's an exponential function, which we'll get into when we get into later stuff. Again, right here, that's not a whole number exponent, right? 5/3. So that ain't gonna work. And then finally, right here, you can see that x is contained inside of an absolute value, which to be a polynomial, you never want to throw x inside of an absolute value. You don't want to throw x inside of like a square root, or because that would make it b to the half power, that sort of thing, right? So you don't really want to do anything funky to the variable, right? So you'll notice that with like polynomial functions, you can have like coefficients that are a little funkier, right? Like you could have a square root of 3 times in with your variable term. That's fine. But just with the variable, just whole number exponents, right? This last guy right here, just I want you to know that like it's a polynomial. Just know that like the coefficients go a little bit beyond real numbers and are complex coefficients. So we would be able to call it a complex polynomial if the coefficients go into the complex numbers and have some imaginary stuff, that sort of thing. We're not going to talk about it, but just know that those things technically would be considered polynomials.